Hello, my name is Mrs Kershaw and I'm a Science Director with Outward Grange Academies Trust. Welcome to today's lesson on rates of reaction. You will need a pen and a piece of paper to make notes as we go along. So if you need to stop the video to go get that, do so now. Once you have your pen and a piece of paper, let's write today's date and the title of the lesson, Rates of Reactions. Our challenge today will be to describe the factors which will change the rate of a reaction, and our aspire will be to explain how the rate of reaction is increased in terms of collision theory. So let's get started. I'd like you to think and write down two things that you might observe, that's something you might see, if a chemical reaction was happening. 30 seconds. Great, how did you get on then? Here are a list of things that you might see if a chemical reaction was happening. So if a gas was being produced, you might see bubbles, you might see a colour change, you might see a precipitate being formed. This is a solid. You might see a temperature change. It's possible you could see light being given out. You may see a change in volume, and you may smell or taste something. But why do reactions occur at all? Here we have a diagram of the element neon. If you think back to when we did atomic structure, neon is in group 0 and has 8 electrons in its outer shell. Neon is part of the group of elements called the noble gases. These do not react, and the reason they do not react is because they have a full shell of electrons. However, other elements do not, so the elements in groups 1 to 7 will not have a full outer shell, and the whole reason that they react is because they want to get a full outer shell and just be like neon. So let's have a look what happens when chemical reactions occur. Here you'll see the particles come together, they collide, and the new product is formed. It's really important that we realise that the collision has to happen with enough energy to react. If we do not have enough energy, then it will just be a collision. We call that energy the activation energy. So in summary, particles have kinetic energy, so they constantly move. For them to react, they need to first collide, and when they collide, they have to have the minimum energy for the reaction, which is called the activation energy. Here's cesium. Cesium is in group 1 and will react really fast. You may have seen sodium or lithium or even potassium in your science lessons. But here's another reaction. This boat has rusted, and that was a very slow reaction. So how can we change how these reactions occur and the speed at which they occur? Now I would like you to think about the factors that might increase the rate of a chemical reaction. So how might we get a fast reaction like cesium rather than a slow reaction like rusting? And as a little bit of a hint, I would like you to think about whether your reactants are a solid, a liquid or a gas, and what the particles might be doing. How are you changing the collisions? Because remember, before they can react, they need to collide with sufficient energy, the activation energy. 30 seconds. What factors did you think of then that might increase the rate of a chemical reaction? Did you get the size of the reactants, the particle size? What about concentration? Pressure, if it's a gas? Temperature, that's one of the more obvious ones. And catalysts, they're a special type of compound that specifically speed up chemical reactions, and we'll look at those in a later lesson. Before we look at the different factors that affect the rate of a chemical reaction, we need to think about how the rate of reaction is measured. So the rate of reaction is the amount of reactant used up or the amount of product formed, and it's all about the time taken. So whenever we're calculating a rate of reaction, which we will do in future lessons, we must always remember that time's on the bottom. It's always about the time that is taken. Let's start by looking at surface area. On the left hand side we've got a large object with a small surface area, and compared to that on the right hand side we have small objects with large surface areas. If you look at the total number of collisions, then on the left hand side you can see that we had 64 collisions, but on the right hand side where we had the larger surface area we had 372, which is significantly more. Now that we've looked at the animation, I would like you to write down why increasing the surface area increases the rate of reaction. And in your answer, you must refer to the surface area and the collisions. 1 minute, off you go. Let's see how we did then. Let's self-assess your answer. So, if a solid is split into smaller pieces, the surface area will increase. The smaller the pieces, the larger the surface area, and this means there are more frequent collisions. We mustn't say there are more collisions because ultimately it will all react, so there will be the same number of collisions, but the frequency of them will increase, and this will increase the rate of the reaction. If you need to correct your answer, pause the video now and use your red pen to do so. Now we're going to look at concentration. So concentration is the number of particles in a given volume. On the left hand side we have a low concentration, and on the right hand side we have a high concentration. If you look at this, you can see that the number of collisions on the left hand side where the concentration is low is only 69, but on the right hand side where we have high concentration and we have far more particles, then the number of collisions was 247. So just like we did before, I would now like you to write a description of why increasing the concentration increases the rate of reaction. And again, you're going to need to refer to the particles. So what's the difference between a low concentration and a high concentration? And what does that do to the collisions? 1 minute, off you go. let's take a red pen and let's self-assess. So, concentration, which occurs in liquids, at a high concentration there are more particles in the same volume. This means that the particles will collide more frequently. Again, it's not just more. If we write just more, we do not get the mark. It is more frequently. And here's a diagram to illustrate low concentration and high concentration. I often think of this as being like dilute juice that you might add water to. The high concentration is what you get in the bottle that you buy from the supermarket, and as we dilute it down to how we drink it, we lower the concentration. There are less orange particles in the given unit volume. Now let's have a look at temperature. Don't forget, watch the particles. So on the left hand side where we have low temperature, the particles are not moving very fast. But on the right hand side, they're moving much faster and they're therefore having more collisions. The total number of collisions on the left hand side at the low temperature is much lower than the right hand side where we have the high temperature. So just like we've done with the previous two, I would like you to describe why increasing the temperature increases the rate of reaction. Don't forget, we need to talk about the particles. What have we done to the particles when we've increased the temperature, and also what has happened to the collisions. Now, there's a little bit of a trick to this one. There's 3 points, so let's see if you can get all 3. 1 minute, off you go. Okay, did we get all 3 points then? So, a high temperature, the particles have more energy. Did we get that one? That means they move faster and they're going to collide more frequently. But there's one other thing as well. Do you remember right back at the beginning we said that for a collision to be successful, it had to have sufficient energy? Well, if we've increased the temperature, then more of the particles will have energy greater or equal to the activation energy. So when the particles collide, they do so with more energy and more of the collisions will be successful. If you need to correct your answer or modify your answer, pause the video now and do so. Pressure then. Pressure is only for gases. If you look at the one on the left hand side, then that is a gas that is at low pressure. The particles are quite far spaced apart. Whereas on the right hand side, the particles have been squashed closer together and the pressure is higher. So why do you think increasing the pressure increases the rate of a reaction? 1 minute, off you go. Last one to self-assess then. So, if we have a higher pressure, the gas particles will be closer together. If they're closer together, that will increase the frequency at which they collide. Again, if you need to modify your answer, just pause the video and do so now. So here's a typical exam question. An increase in the temperature of hydrogen peroxide increases the rate of reaction. Use your knowledge of particles to explain why this would be. This would be a 4-mark answer. So we're going to bug this question. First of all, it's an explain question. And when we have explain questions, we need to say why something has happened. A good connective to use in this type of question is the word because. We underline our keywords when talking about particles. So particles must form part of our answer. And then finally, when we glance back over the question, we're looking at temperature and the rate of the reaction. So we need to be talking about the particles, what increasing the temperature has done to the particles, and how that has then increased the rate of reaction. 4 minutes, 4 marks, off you go. have a look at how we got on then. So at a higher temperature, the particles have more energy, so they move faster. If they're moving faster, the particles will collide more frequently. And then critically, just for temperature, if the particles have more energy, then more of the collisions are successful. How did you do? Well, that's the end of today's lesson. The following 2 slides contain a summary if you wish to record it in your book. It might help if you pause the video if you need to. Other than that, don't forget to fill in your Google form and submit your answers to your teacher. Bye.
So if you'd like to write a summary of what we've gone through in today's lesson, that will follow on the next few slides. You can pause the video if you need to. And if you're happy with what you've written, then you can go straight to the Google form and answer your questions for today's lesson. And then maybe have a go at the extension tasks.